Hi, this video is about trying to bring this rotator back to life. For those of you who've watched some of my other videos, you remember I'm a returning amateur. I've been on the air now for about 7-8 months, having had a break at 30 years. This is my old rotator. It was second hand when I bought it in the early 80s, so I suspect it's a late 70s model. It's a Aiga ART-3000C. It's a Japanese rotator and it's a sort of medium size, so I had 2 VHF beams on the top of this. Basically it came off my mast when I moved house and went in the loft. I gave it away a few years ago, but it wasn't being used and I was offered it back, so I don't think it's been outside at all. It's been in the loft, so I'm planning to connect it back up. You'll see here I just cut it off when I left it, and also this grease will be long gone by now inside. Hopefully it'll all come apart and get it connected again. I always was missing 2 switches. I don't know whether I'll find anything that'll fit in there, but you can push your finger in and rotate, and the needle tracks the position of the antenna. So hopefully this is a fairly straightforward job of disassembling, greasing, reassembling and a bit of soldering, but who knows. Thanks for watching. Now, tempting as though it was, I didn't plug in the rotator to see if it works, because this is probably heavily gunged up with old grease, so rather than put any strain in it, I thought I would disassemble it first. So just in case I can't line it up again when I've finished, I'm just going to mark this so I know where it was. I'm not sure how it works in terms of linearity of the rotation, so I'm just going to put a mark on there, and at worst I can always get it back to where it was. Well, that's a theory anyway. So I'll disconnect this cable, undo these 4 bolts, and see what lies behind. So a lot of sticky electrician's tape later. I'm down to the final plug, and there was no self-amalgamating tape on that. That must have been too small, the diameter. I've obviously packed that out. That seems to be okay. We're assuming that unscrews somehow. I might have to put some pliers on that just to get that off, but it looks okay so far. So I've got some adjustable mole grips to slacken that. That looks okay. 30 years later. Well, that's a start anyway. Things looking reasonably okay. So now to loosen the retaining bolts, which are 10mm. And that wasn't tight at all. Neither was that one. Bit slippy on the old grease. That one's tight. That one isn't. So I'll just get a better grip on this one. There you go. I shall take those off. So those 4 bolts came off easily. I'm holding this together. I'm expecting it to part here, and there to be 2 ball races inside. I'm not sure if they're loose or they're going to be held or what. And that still looked okay actually. A few ball bearings to find on the floor, but everything seems well greased inside. Yeah, that doesn't look too bad actually. Right, I'm going to now find all the ball bearings that have dropped out. So here we are with all the ball bearings out. There was 47 on the top race and 48 on the bottom, unless I've lost one on the floor somewhere. I'll have another look. But you can see the grease on the actual teeth, the cogs of the rotator is still lubricating the rotator. That's fine. I noticed the ball bearings that were on the bottom race were slightly more claggy, shall I say, in terms of the viscosity of the grease than the top one, so I think that one's had a bit more weather exposure to it. But it's a case of cleaning the bell housing over here and the bottom race as well, getting these ball bearings cleaned up and put back in with some lithium white grease, and just checking that I haven't lost a ball bearing on the floor. So these are the bottom race bearings before they've been cleaned. These are top bearings. They're currently sat in lighter fuel to degrease them, and you can see they come up like new. So it's not too hard. Just rub the thick grease off with some kitchen roll, some towel, and then clean them with some degreaser. And like I say, I've used lighter fuel in this example. Now I have to say that was a really messy job, degreasing everything. Went through a lot of paper towel. So now you can see the top bell housing. That race is all clean, as is the bottom one. I had to go at cleaning the old black grease off the bottom as well. That's the gearing for the rotator motor, and that little peg there is the stop marker. There's a variable resistor on the top, and that sends the signal back down to the controller. And you'll see I took the bottom mast bracket off just to get this bottom ring off below it. So it's all clean now. I think I was a bit too hopeful in making that red mark at the start, because there's going to be some alignment and collimation needed, I think, in all of this. So now a case of greasing it up and getting the ball bearings back in and putting it back together. But before we do that, I'll just share with you my thinking on this in terms of aligning the rotator. This is the first and only rotator I've ever taken apart. That's the end stop with two micro switches. So on the grounds that that display has two ends of south, I'm assuming that's south, so that's north. Now there's that mark there, try to do this one-handed there, which corresponds to that switch. So when I put this back together, that needs to be down that end to connect with that if we were going for south. So due north is that mark at the top. And in terms of the resistor, the gap in the resistor is at the very top there, this variable resistor. So when that hits that end stop at south, that's one south, and all the way around is the other south, remembering that that's what the two ends are. So north in the middle. When I put this back together, I think that wants to be directly opposite that stop bar. And in the top bell housing there's a little indentation that takes a little plastic peg that goes on that, and as the rotator turns, that moves round, changes the resistance of this 600 ohm variable resistor, which goes back down to the display, and the needle moves. In theory, when we get the end stops, this max rotation light lights when these micro switches click. Now before I put all the grease back in and the balls, I think I'm going to wire this up now, and just to check that all this actually works, because it looks okay and it hasn't been used, but I think I'd rather know it worked before everything's covered in grease, because that could be a bit of a nightmare to undo once I've done it. But the ball races are all fine. There's no pitting, no dents, nothing. In some pictures of rotators that have been sat, you can see dents where balls have pushed down into the race, and there's none of that on this rotator. Right, so I'm going to connect it up and see what happens. Aye, so you join me sometime later. I've added a new mains lead to the control unit. I've reconnected the control cable which was 8 core. That was fun. And if I power it up, so we can see how this this variable resistor works. Moving off to one side, you can see how that works. Now there's a contact point. It's basically just a long loop of resistor wire running round a former, and where the rotator had been parked, which is roughly where it is there, the wire had broken, and I'll just post a few photos after this section just showing you the connection I had to make. It was really difficult. I had to use a jeweler's eyepiece. My soldering tip looked ridiculously large, but I managed to get it fixed. So you can see here, if I go off to the west, there's a little bump there, but then it goes past, it keeps going round. And in terms of the motor, if I power one way, and then the other way, and if I just move that back a bit so you can see the maximum rotation, that's these switches here. If I rotate, there you go, max, and if I rotate the other way, max, and the light shows up there. So everything seems to work. It just needs re-greasing up now and putting back together. Fingers crossed it'll all work when it's back in one piece. I've greased up the main gearing, and I've added the main gear wheel on. And if you remember before, I said about this peg here, this is going to be north, and when the rotator's back together, it's this that catches the micro switch for maximum rotation. So I'll just show you the rotator turning now and how that works. You can see it catching, and then you get maximum rotation. And as we come off, it releases the switch. At the start of the video I think I said I was going to use white lithium grease. Lithium grease seems to be the best recommended for rotators. I've got this, it's not white, it doesn't really matter, and I've already put some grease around the race. This is the bottom race, so you're not smothering the race or the balls. There's just enough there to hold the ball bearings in place. So you can see there the finished race greased up. It's not smothered in grease. There's just enough for the balls to sit in, and then just a light coating on the top. Now I can't put that bottom race on until I've greased the top race, and then that bolts on and they both meet together. So now I've got to grease the top. So there you go, that's the bell housing and the ball race all greased up, and now it's just a case of putting it back together. And just to show you, you don't use a lot of grease. I've just gone into the end of that tube there, and most of that ended up on kitchen towel. So you just enough to lubricate the ball bearings, and once it's rotated a few times, the grease will settle on the balls and lubricate from there on in. You have to remember, a rotator isn't getting much rotation in terms of similarities to say a car wheel. It's going very slow and not very often. So now a case of putting all this back together. So here we are with the rotator all back together apart from the bottom bracket, and now if we power on, I've marked up a north label and a south on the other side. I put it back together with what I thought was north at the right setting. So if I adjust this calibration, and then if we move around to south, you might want to fast forward this bit, it might be a bit boring, but here we go. And there's the needle up, there's the needle jumping. If I just go back a bit, you can see where I soldered the resistor. The contact's just catching, but it's just how it has to be, unfortunately. And it frees up. So coming round to west. Around to southwest. And south. And there's the max. Now that's gone right full scale. I think that's possibly something to do with my soldering and the way the resistor works, but it's definitely south. So I'll take it back round to north, and then we'll go around to the other side. So here we are back at north again, and we'll go around to the other south through east. And again, this might be a bit monotonous, you might want to fast forward. So through northeast, it's looking quite linear in terms of what the reading's showing and where the rotator is. East, that looks bang on. Southeast, that looks fine as well. Right, so I've reached south on the meter, but not south on the rotator. That'll be to do with my soldering of that resistor. It's obviously affected the resistance as it moves around. There's max rotation, you can see the light. So I can adjust the calibration knob, but then north might be out, so I just need to fine tune that, but seems to be working okay. It's gone back together okay, and it's ready for action again. So if you have got an old rotator that you think's a bit past it, well, this one is at least 40 years old and it hasn't been used for 30 years. So it just shows you can breathe life into a new rotator, and into an old rotator, sorry. And this will go away ready for when I start looking at VHF beams, which I don't have at present, but that's where this will be used in the future. Hope you've enjoyed the video. It's been a bit specialist, clearly for this rotator model and make, but I'm sure other rotators are quite similar in design and build from this era anyway. I hope you enjoyed the video.